All right, in this video, we're looking at how to handle rational exponents. I just want to show you two quick examples to kind of start out the process. The first thing I want to show you is x to the 1/2 power. What you can do with this expression is actually express it as the square root of x to the 1 power. And the reason why that is because this denominator of the rational expression can swing around to the front and become the index of the radical. So it'll be the square root of x to the 1 power. Now, that's very convenient because every time you see x to the 1/2 power, that's the same as the square root of x. If you saw x to the 1/3 power, that would be the cube root of x, etc., etc. So if you look at another example, y to, let's say, the 2/3 power, what that will be is the same as you bring the 3 around to the front, becomes the index of the radical, so it'll end up being the 3rd root of y squared. All right, so with those two examples in mind, I want to write this as 16 to the 1/2 power raised to the 3rd power. And if I do that, what that's going to do for us is allow us to use this idea that anything to the 1/2 power is just the square root. So I can say that 16 to the 1/2 power is the square root of 16. And again, just to make sure you're aware of why this is equivalent to what's on the left, the 3 times the 1/2 would be how we simplify this expression, and it would end up becoming 16 to the 3/2 power. So you can always do that. You can always separate the numerator, or the denominator for that matter, of your rational exponent and rewrite it the way we've done here in example A. Now, with that in mind, we can go ahead and say that the square root of 16 is the same as 16 to the 1/2 power. And then from there, we have that little 3 outside, and the square root of 16 we know is 4. And then if we raise that to the 3rd power, we end up with the answer 64, because 4 times 4 times 4 is 64. All right, very good. So that's the first one. The solution for example A is 64. All right, let's look at example B. For example B, we have a similar problem. Let's use the same exact approach. We're going to say negative 27 to the 1/3 power, and we're going to put the square on the outside of a parenthesis, outside of that. Then we can say, what is the equivalent to negative 27 to the 1/3 power? Well, remember, this will swing around to the front and become the index of a radical, right? So we're going to end up having 3 here in the index position, and then minus 27 to the 1st power, which we don't have to put the exponent on it because it's the same as just minus 27. Then on the outside of all that, we'll have the square. Okay, from there we're going to do the 3rd root of negative 27, which is negative 3, because negative 3 times negative 3 times negative 3 will give you negative 27. So from there, we'll square that and get the final answer of positive 9. All right, let's do our last example. Our last example is example C, and we're doing negative 1/8 to the 1/3 power. Well, to solve that one, we're going to use the same procedure we used before. Remember, anything to the 1/3 power is the same as the 3rd root, so we'll say the 3rd root of negative 1/8. Now, from here, you could go ahead and tackle it using the whole fraction, negative 1/8, but what I want to do is use the trick that allows us to split it up into numerator and denominator. So I'm going to take the 3rd root of negative 1 in the numerator, and then the 3rd root of 8 in the denominator. From here, you'll see that it's very easy to evaluate because the 3rd root of negative 1 is just negative 1, because it's negative 1 times itself 3 times, that gives you negative 1. And then for the 3rd root of 8, it's just 2, because, of course, 2 times 2 times 2 is 8. So our final answer then is just negative 1/2.